zoom in and, ooh, be a little clearer. There we go. Okay, so chapter 10, lesson 5, we are moving on to the Pythagorean theorem, which actually I should say moving back to, because if you took the 8th grade curriculum, you worked with the Pythagorean theorem at great lengths last year, okay? So if we have a right triangle, so quick overview for those who are forgetting, if you have a right triangle, so a triangle with a 90-degree angle, your two legs are usually labeled A and B, and then your hypotenuse is always C. Your hypotenuse is always the longest side, the one across from the 90-degree angle. And if you know two of those lengths, you can use this equation to solve for the other one, and we know how to do that now because we've been dealing with radicals so much. Okay, so we can use that. Now, specifically, a Pythagorean triple is it not only would the three numbers fulfill the a squared plus b squared equals c squared, but also the three numbers will be integers. That doesn't happen very often. Here's your most common triples, the 3, 4, 5 triangle. Some of you guys might remember that. I remember this one all the time, and this one too, but I'm not going to lie, these two I tend to forget about. I just do. I forget them because I'm not as familiar with it. They're numbers, I think, because they're not as close together. You kind of forget. So, but these are a Pythagorean triple. In order to be a Pythagorean triple, it has to be integers. Okay, so if it satisfies the Pythagorean theorem and they're integers, then it's going to be a Pythagorean triple. So the first couple questions just give you three measurements and asks you, can it be a right triangle? Remember, C always has to be your biggest one. So if this one is a right triangle, then 14 squared plus 15 squared better equal 19 squared. Okay, so that's what we are going to determine. Just get out your calculator if you don't know these. 14 squared is 196. 15 squared is 225. That one I know. 19 squared is 361. And so 196 plus 225 is 421. They are not equal, so not a right triangle. Angle. All right, that's simple. And if it's not going to be a right triangle, well, then it's not going to be a Pythagorean triple either. So you can move on. Okay, down here on the second example, 30, 40, 50 can be sides of a right triangle. We'll find out if you need to do this. 30 squared plus 40 squared. Now, some of you, maybe I just identified, hey, it's a 3, 4, 5 triangle. They're just all multiplied by 10, which is true. So this is 900, this is 1600, this is 2500, and they are indeed equal. So not only, yes, it's a right triangle, and Pythagorean triple. So that works. Okay, let's turn it over because they're not all going to be this easy because, you know, that would be 8th grade math. So they're going to make it a little tougher. They're going to make it a little tougher. Check this out. Okay, so here we are. We're actually going to use the Pythagorean theorem to solve for a leg or a hypotenuse, a missing length of some sort. Take a look at this first example. You'll see the hypotenuse is the one we're missing. So we've got 9 squared plus 12 squared equals c squared. All right, this is 81, this is 144. And 81 plus 144, just double check in my mental math, yep, okay, is 225. Now, we take the square root of that to find out what c is, and 225, is that a perfect square? It is, all right, so it is 15. Now, if it's not a perfect square, we know how to simplify radicals. Okay, so let's go over here, round to the nearest hundredth if necessary, even though they're not asking us to find radicals. I guess they're asking us to find decimals. So take a look at this one. Now in this one, you'll see that they give us C, and they label it A, but it really doesn't matter. It has to be on the side where you're adding them up together, and it has to equal 37 squared. Whether you put 19 squared or A squared first or second, it's really moot point. So we got 1369, and 19 squared is 361, I'm pretty sure, double checking again, yes, 361 and a squared. See, in this one now, we can't just add them together. We have to actually subtract the 361. That's what happens when you have one leg missing, all right? So 1369 minus 361, and we get 1008. Take the square root, and your answer to the nearest hundredth, that's 2 decimal places, will be 31.75. And usually I'd say label it, but I didn't provide you a label. So 31.75 units of some sort. I guess I could put a generic on there. All right, let's keep going. Popular equation, popular word problem. We got a ladder against a house. It's 14 feet long. It's leaning against the house. How far up on the house is the ladder? How far from the house? So obviously the distance from the house is what we're trying to find. 14 is our hypotenuse, so whether it's d squared plus 12 squared equals 14 squared, or 12 squared plus d squared equals 14 squared, it doesn't matter. So 14, I think that's 280, oh shoot. Yeah, 196, just my brain's not working, and 144. Oops, plus, so we subtract the 144, and d squared equals 52, right? 196 minus 144. 52 is not a perfect square. It says round to the nearest tenth, so tenth, 1 decimal place. So take the square root of 52, and we're going to get approximately 7.2 feet. Now, what if they give us radicals? Extra example just because I think you can handle it, because we've been dealing with these radicals. Take a look at this. What if our legs that they give us have radicals in them? So a and b, square root of 5 squared plus square root of 23 squared equals c squared. Well, that kind of undoes it. I got 5 plus 23 equals c squared. And 5 plus 23 is 28 equals c squared. And just to keep in the spirit of radicals, c then, if I am going to simplify it as a radical, would be 4 times 7, or 2 times the square root of 7 for that one. So be prepared to give your answers as radicals. That is all of today's lesson. In lesson 6, we're going to go on and talk about the sine, cosine, and tangent, which is trigonomic functions. Bring your calculator. But for your assignment here, it's 2 pages. It's not that you're 2 pages. Okay, so 10 through 18 even, 19, 20 through 28 even, 62 through 80 even, and that doesn't fit on one side. So that's why you have a 2-sided. All right, if you have any questions, I don't anticipate them, but if you do, please come and see me and I'll help you out. All right, especially those of you who managed to skip over that 8th grade curriculum, this might seem foreign to you. You maybe have not seen the Pythagorean theorem, and I went pretty quick. So you can always come check with me, and I'll help you out. Okay, good luck.